All right. Thank you, everyone, for coming to the Van Essen webinar. Today's topic is the CTD-Diver, and we appreciate you carving some time out of your day to join us and listen to us talk about it. Hope you learned something about the CTD-Diver. So again, thanks for joining. If you have any questions, please use the chat box or the diver. We have a diver inbox in case you weren't aware of that. But of course, there's somebody had to have invited you. Please reach out to them, be it a distributor of ours or your representative directly from Van Essen. So introducing your representatives, Jonathan has been with Van Essen now for 3 years, but he brings a wealth of information to the table with 35 plus years of field experience in a previous job, and of course the experience he's gained while working with clients at Van Essen. Jonathan is in Atlanta, Georgia. That's where his home office is, and that's where he's based. He looks after everything east of the Mississippi. That's our dividing line. I look after everything west, and I currently reside in my home office is located in Tucson, Arizona. I've been with Van Essen for 15 years. I bring to the table probably 20 years, I would say, of environmental and water experience in previous jobs and in this one as well. What is the CTD-Diver? Well, it's a unit that we have that we add actually the only other parameter outside of temperature and depth, and that is conductivity. Conductivity is a measure of electrolyte solution's ability to conduct electricity. Our available units of measure within the software under preferences is millisiemens per centimeter, microsiemens per centimeter, of course, Siemens per meter. Our temperature is measured in either Fahrenheit or Celsius. The depth is a direct translation of pressure to water level within the software, and it's really water column above the pressure transducer, which is where you can see the etched line on the CTD-Diver. Available units of measure are both imperial or metric. These units are completely self-sufficient with memory and battery being inside. Applications for these units, and what we've found probably are most common for us, although it's not limited to this list. I know there's other applications that I've certainly probably forgotten about that we've applied the CTDs in through our clients. Applications include, and probably the most popular for us is the coastal studies with salinity and saltwater intrusion happening on those coastal regions. Injected wastewater, aquifer storage and recovery. These projects were quite popular when we were combined with another consulting firm working head to head, but it's still quite popular, making sure that especially the wastewater applications aren't getting out of their aquifers and into native groundwater, or at least their containers, I should say. Remediation sites from chemical discharge, and we know there's any number of remediation sites and Superfund sites all across the United States. You'll find on these sites tracer tests are quite common with bromine. The CTD is an excellent indicator of when these tracers hit their intended targets on these sites. Landfill and mining sites, agriculture and storm water runoff. There's a pretty big project that our colleague to the north in Canada is working with a government agency on, and that is monitoring the snow melt and how the salt that's used to treat the roadways is affecting the environment, and they're using quite a number of CTDs on that project. Estuaries and wetland research programs. These are some of the couple things that I'll be mentioning in more detail in the next few slides. The most common, of course, we've already mentioned salinity and saltwater intrusion. Here's just kind of a look of what the graph would look like. And this is out of our Diver Hub, which is the web portal for our telemetry. This is just showing both the diver's pressure and then the conductivity. The picture to the side is an image of a river and somebody working with our CTD. and they're monitoring obviously for saltwater intrusions and tidal influences, tidal fluctuations, and how everything ties together. Pretty neat project. Mining sites, which I became quite familiar with over the years that I've been in Tucson, especially with the copper mines that that make up this region, and that goes, you know, on from the beginning stages of a site being picked in the exploration phase, all the way to closure and everything in between. Really important is the environmental or regional wells. These wells tend to border property lines in the mines. They're making sure that they're not leaching anything in places that they shouldn't be. These are just things that happen in some of the more modern mines, certainly. Heap leach, taking the waste rock, percolating some chemicals through to get the reaction, and then ultimately recovering the oil for the ore rather for processing further. If they've been doing this in some of the older mines as a modern solution for extracting more ore in a cost-effective manner. And of course, tailings ponds, making sure that they're not, as they're making these more base, that they're not in fact infiltrating the aquifer with any pollutants. Monitoring these with wells that are put around the borders. Mine closures, another important thing for more modern mines. As we see things close, there's more policies in place than there ever have been. Just making sure that these over the years aren't contaminating the environment. Probably my most favorite clean water application is estuary and wetland research programs. I love being involved in these. I think they're really unique in the way they're made up. And there's a picture here. I'm not sure where the top picture is, but I know Aruba is the second picture. No, I didn't go there to take it, but we do have our units working in those locations. And just these are not limited to any of these names that are in this list, but you know, retention ponds, bogs, swamps, coastal plains, and salt wedge projects, where let's say the fresh meets the salt, salt water, and those delicate little ecosystems that exist within those, and how salinity can play a part. They're using CTDs to, you know, show that there is in fact, let's say, a decline in salinity and an increase in the life forms and their reproductive rates. Fill in the blanks what those are. Could be anything, but yeah, the CTDs are working very well in these environments. So the makeup of the CTD, we like to call them rugged and accurate, and rugged from a sense that they're corrosion proof with their zirconium or ceramic housing. These units are already fully corroded and could withstand quite a few nasty things that are thrown up against them all over the place. You have your specific or true conductivity. Also user selectable is the conductivity range, picking 0 to 30, 120, or 300 millisiemens per centimeter. We'll get a little bit more into this in the next few slides, but there is a 4-point user calibration, and I'll show you the wizard as well as the standards you use for that. But these units, when you purchase them, there's nothing that needs to be done to them. They're fully calibrated and really ready to go out of the box. The ranges for our units are 0 to 33, 164, and 328 feet. Now that is the maximum recordable water column that can sit above these divers in whatever application they're in. What it does once it exceeds that range is that it'll flatline until that water level drops. And once that water level drops, you'll start to see the fluctuations again. But you know, try to pick the one that best fits your needs, and keep in mind that we do max out at 328. Sample methods, and these are all available on our website, what each of these means. Briefly, fixed, obviously, set it, and it'll go to that 1 hour, 1 minute, 1 second measurement. Event-based is similar in that it's going to look every 1 hour, 1 minute, 1 day, but it's only going to record if it sees a change on a percentage that you've indicated. Averaging is pretty straightforward. And then pumping tests. The nice thing about pumping tests is that we do have preloaded tests that are in the software that you can choose, and it'll tell you what each of them are. or you can customize your own pumping test to your needs. The units are very easy to maintain. There is virtually nothing you need to do to these in terms of the outside of these units. They're easy to clean with a corrosion-proof surface. It usually just wipes away or washes off. But in the event that you need to do something a little bit more, typically just soaking it in a vinegar solution, either for a couple hours or overnight if you can, and then rinsing it with distilled water, you're ready to go, or you're ready to move on to the next step. Something else that can keep the units, certainly the C cells, from biofouling is by adding a copper shield. This copper shield can be purchased separately. This unit slips over the back of the diver and onto the C cell, and significantly reduces the maintenance visits to site and maintenance costs associated with that. We had one client in Florida that was going out every 6 weeks because it was getting gummed up with some form of algae. I can't remember specifically what it was, and then virtually rendering the conductivity measurements useless because it would plug it all up. After they cleaned it out with a pipe cleaner and put it back in place, they knew they had to be back out in 6 weeks. But we introduced these, and it has been about every year that they need to visit. So there's a significant change in their number of visits, and they're quite happy with that. Recommended calibration for these units, we typically say every 6 months, maximum 12 months if you can. Make it at least once a year, or at least follow your company's field instrumentation standard of practice. Technical specs on these units are here. You can see the sizes off to the side. This unit will fit in a 1-inch well and have plenty of wiggle room. The housing material I've mentioned a few times now, but I'll say it again, is ceramic and is zirconia. The memory recordings capability for this unit is 48,000, and that is the conductivity, temperature, depth, timestamp, date stamp, those 5 pieces, one measurement, 48,000 times. The sample interval for these units is 1 second or 99 hours, or absolutely anything in between. It's your choice. The typical accuracy for this unit, and keep in mind this is full scale for whatever you select in terms of conductivity and its range, is plus or minus 0.1% of that full scale. And you can see these units, not only are they compact, but they are also quite light. At 3.4 ounces. So just a little bit on specific versus measured conductivity. Again, these are both selections that you can make when you're programming the CTD. The specific conductivity of an electrolyte solution is defined as the conductivity if a solution is at a certain reference temperature. And really it is just detecting or measuring the presence of dissolved solids that might be in solution, be it iron or phosphate or nitrates or chlorides. These are all key indicators of water pollution. So typically you'd want to select that method when you're in a, let's say, a mining or a landfill leachate application, and you want to, for instance, in the case of a landfill, make sure that the liner's working. By putting CTDs placed strategically around the landfill in monitoring wells, you can certainly detect when the liner has failed and pinpoint, not precisely, but certainly from approximation where that leak is coming from. Conductivity, if you choose that method, just keep in mind it's highly dependent on temperature, or temperature dependent rather, approximately 4% per degree of Fahrenheit. This equation is what is used for conductivity, certainly when it comes to our unit. So just keep that in mind. If you want more information on this, we can certainly pass it along. For now, just memorize it and be prepared for a test at the end. Didn't give you time to have a screenshot. Verification. So verification for the CTD, and this is basically as it pertains to conductivity as well, relates to just simple tests that you can do to see if these units are functioning within spec or to your specifications, or what your expectations are. Step one, remove the CTD from whatever it's in. Just getting it as a solution. You can have this hooked up to a computer with a PC interface cable and just hovering it above the water level if you wish. But the open air reading should be 0. Sometimes it might not be, it might be very close. It might just mean that there is a solution that's kind of lingering in the C cell that needs to be rinsed away. Either dip it back down in the solution where it's come from, or bring it out and rinse it off with water. It should be back at 0. Step 2 for verification of these units functioning within their intended guidelines is to immerse it in a standard and compare these with the value of whatever calibration solution you have it in. As far as calibration goes, it's very simple, it's very quick, and it's all done by Wizard within the Diver Office software. There is 4 standards that you can choose from. You can do all of them if you wish, but we recommend just picking the one that is closest to whatever your lab matches your lab samples from the location that you're doing your field work, and then just pick the standard that matches closest to that. Hopefully it's one of these 4, and from there it is swirling the solution, swirling the CTD, either using a reading unit holding it tight in place, or one of our cabled solutions. Swirl it in place, and within less than a minute, that unit should give you an indication that it has been calibrated by clicking that calibration button down here. This is what it looks like in the software, and you move on to the next CTD for calibration. But the nice thing about our unit is no matter who's going out to do this, if it's one person, 1 month, or 1 quarter, different person, the next time that goes out, they don't have to carry the same exact computer. They can carry the one that they use in their own field applications. And then just know that the information is stored when it was done last, and the result of that test can be viewed when they're connected with that CTD in the field. Here's some of the projects. Now I mentioned projects in the US, some of the applications that we've supplied these units to our clients and where they're being used. Some of the other unique locations, and there's quite a few CTDs working all over the world. A nice chunk of these have been deployed at Anna, Peru, which is a couple of cities managed by this water group, this Anna group. And they've combined their efforts to get 150 of these CTDs, attaching them all to a cabled solution. And you can't quite see it, it's out of the image on the right here, but it is in fact connected to a diver link. This is a view of our DXT cable. It looks like a nice installation. They've got it geared to fit the diver link perfectly with some kind of contraption there. But ideally what they're doing with this information is they're monitoring for obviously for water levels and availability, but also water quality with the CTDs. And the information they get from this, combined with other information, they're able to supply potable water to the people they distribute to in these 2 cities, Tacna and Ica. Another project where there's quite a few CTDs deployed is the Western Coastal Project in Saudi Arabia in the Middle East. This is basically bordering on the Red Sea, where these divers are deployed. These units, excuse me, these units are helping them to basically learn about the saltwater intrusion. Where they're mapping it, they're looking at the flow paths, and they're looking at also the interaction from when one particular pump is turned on, another one's off, and how these are all interacting together, and the flow obviously of the salt water and ultimately where it's going. Diver suite isn't just comprised of one diver. The one we were talking about is off to the far right, the CTD-Diver. We also have a few more in the family. The first one is basically our starter diver. It's called the TD-Diver. It's the latest iteration to the family as far as where we are generationally with divers. This unit measures for temperature and depth, much like the CTD, as I mentioned before. This unit is very cost effective for the quality it's putting out, and this is a real workhorse as far as data loggers go. This diver, you set the fixed rate. That's the only choice you have with this unit. Although you do have very fast sample rates that you can do with it. But this unit is set it, fixed rate, and then go till it's full, or you need the data from it, and you pull it. You can re-zero it by stopping the diver and restarting it. So the TD is the long-term monitoring solution. The next diver over is the barrow. I always say that no network is complete without the barrow, because I don't know if you can tell from these images, but our units are completely sealed, and there's no influence from atmospheric pressure in terms of these units being vented. They're not. We are absolute only. A barrow can work in a 15-mile radius with whatever number of divers you have deployed there. These units, you just deploy one, covers that network of 20, 50, 100 in that 15-mile radius. But keep in mind that if there is a change in elevation of 1,000 feet or more, you may want to consider adding another barrow so that your readings are properly corrected. The smallest diver that we have is also the smallest on the market. Nobody can beat this unit. It's a little bit larger than a chapstick. This unit fits in a 3/4 inch well with wiggle room. It is also short, so it bends around corners quite nicely. This unit is where we start to ramp up the electronics in terms of what they're capable of. We're moving away from just providing the fixed. We now add event-based, like the CTD, averaging, and preloaded pumping test, and obviously customizable pumping test. The next diver over is the Sarah diver. This unit takes into consideration all the best features of all of these units. The accuracy of the TD-Diver, the electronic functionality of the ramped up measurement frequencies of the micro diver, and also the housing, the rugged housing as far as what it can withstand of the CTD. And a nice package with the Sarah diver. That's a little bit on those divers. If you want more information, please let us know, and we can provide that by brochure or pointing you in the right place for the website. Here's a cross section, and this is what things would look like in Ana, Peru with their project. Mind you, the diver that they have is the CTD. There's our DXT cable connected to the diver, and ultimately to the diver link. This is just a cross section. What is diver link? Well, we did do a webinar on this a couple months ago. It was uploaded, I believe, last month. We'll send you a link to that. Diver link is essentially a modem that uses a cell network and can be deployed in any format that you wish. It's mountable to hard surfaces. The flush mount situation, if you need to run an antenna out, we do have an external antenna available for that. Most popular so far in stick-up wells. And then there's surface water applications where we have these deployed now. It transmits, as I mentioned, cellular network using 3G or 4G. We provide a world card for these units. There's no need to negotiate or go find the right network provider. It's going to pick the strongest signal in that area, and if it's not picking up a signal, it's unfortunately just not going to work. So that's something to take into consideration. But again, it's not working with any one provider. It picks the strongest signal. These units are easy to deploy, very durable. You put in 2 batteries inside. They're lithium size of D-cell batteries. You plug those in, you close it up, hit it with a magnet on the side, and the face of it, you'll see there's 4 lights that'll light up, not in this situation, but they do. And once they're all green, that unit is ready to go. It's deployed, and then the work just happens online with your username and password that you get for the diver hub, and you're going to feed that diver hub information about that well, serial numbers, and once that's done, it'll start pushing data to the hub that you can access by, again, username and password. Pretty excited to announce that last month we launched the DiverLink triple version, and you can see here from the picture that if you've got wells that are close together, You can tie them all into one modem, reducing your costs essentially for what the needing to deploy one-to-one. Or in some cases, you may want to have 3 different divers in one well, looking at different zones inside that well. So there's just a couple of unique ideas for the triple link. Our end of the year sale doesn't take away from the triple link. I hope that's pretty exciting news. But this is something I've never seen in my 15 years. But for this month and next month, taking us to December 31st, we've decided to reduce the cost to you for the CTD. The units will sell for $1,295 instead of $1,995. This is valid to U.S. customers only. And we've thrown in a little something fun for the first 25 customers. You'll receive a free reading unit. So just let us know if you need a quote for that. 1, 2, it doesn't matter. They're all $1,295. So you're getting a really good piece of equipment for significantly reduced price. And that expires the 31st again of this year, or of December, or while supplies last. So here's the information that we're going to be sending in a follow-up email to you, so you can go look at the CTD information for yourself, explore the software if you've never done that before. Also, there were some distributors that were invited to this that may have been responsible for you being here. I know there was a distributor that also attended today. Thank you for being here. And if you have your favorites that you like to reach out to, then by all means, just compare that to our list so you can verify that they are in fact an authorized diver distributor, and ask away for a quote. They've already got the information and the know-how. A little more information will be sent to you as well on DiverLink. Again, the link to the YouTube. And what we'll do now is thank you very much for your time. It's been our pleasure to present to you the CTD-Diver. We're here for questions, support, tech support. If you need a quote, just reach out to one of the 2 names here, or again to your distributor. We're just going to cling on for a few minutes just to see if there's any more questions. I noticed a few of these questions were flooding in, throughout the presentation. So we'll leave it open until things start to die down. But thank you so much for being here. We're really glad you were here. Thanks.